If you're new to game development or coding in general, you might have heard the term source control and not known what it was. Or worse, you haven't heard of source control until just now. Either way, I'm here to give you an intro to the basics of one of the more popular source control systems, Git. While the whole of Git can be overwhelming, the stuff you use every day is mostly straightforward, and that's the stuff I'll be covering in this video. Let's get started. Okay, first up, what even is source control? Basically, it's an annotated history of your project. It shows when something has changed and, generally, why. It also makes working in a team easier because it helps manage the merging of those changes. Say someone on your team modified part of a file that you've also been working on. Without the help of something like Git, you'd have to be super careful with not saving over their changes. But Git isn't just for teams. It's also a great tool even when it's just you. It helps organize the work you do and gives you a bit of a safety net in case you make a mess and want to roll back. Okay, let's install Git. I'll talk about graphical interfaces later in the video, but to start with, we'll be talking about the command line interface. Depending on your system, the installation will be slightly different. On Windows, you can download the installer. On Mac and Linux, there's some commands you can run, or it might already be installed. Once you have Git, you can run git ---- version to check that it's ready to go. The first thing you need to do is initialize a repository. Just a quick side note, I'm using Linux, which for the most part has the same Git commands as Windows and macOS, but some of the other commands I'll be using to list files, etc. might be slightly different to you. Also, this is a Godot project, which doesn't really matter for the purpose of showing Git stuff other than the git ignore file that I'll talk about soon. So once you navigate to the project directory, type git init. This will set up some basic git config in this directory and create an initial branch called either master or main. Don't worry if your command prompt looks different to mine. I'm using a thing called Starship for my prompt, which I'll link to in the description. If you show all files in this directory with ls-la, you can see that there is a hidden Git folder. If you want to remove the Git repository in this project, then you can just remove that folder. You generally don't need to know what's in that folder, or really even that it's there. I'm just telling you in case you discover it by accident. So, with our Git repo initialized, we can get a status by typing git status. This tells us that we have a bunch of untracked files. Untracked files are just files that Git doesn't know about yet. There are also a couple of things missing from this list that you would see by listing the directory manually. That's because those files and folders are being ignored by Git. Git looks for a special file called gitignore that contains patterns for things it should keep out of source control. Generally, those files are things like logs, derived build assets, or individual settings. Godot projects start with a gitignore file that contains some stuff that Godot says you shouldn't put into source control. Now we can make our first commit. But first, I just want to thank my patrons for helping make this video. If you want to see more of these videos or get access to a bunch of handy Godot stuff, then become a patron today. Okay, back to Git. A commit in Git is like a snapshot of related changes. After you've done a thing or fixed something or some other generally atomic task, you should probably commit those changes. It's kind of like saving your game. If something goes wrong ahead, you can come back here and try again. Actually, just before we do that, we should make sure Git knows who we are. You can set your name and email with these commands. And you only need to do this once, and then Git will use it for all commits on all of your repositories. Git uses a concept of staging files to add them to the next commit. So we can add files individually, by folder, or all at once. Since this is our initial commit, we can just stage everything at once with git add dot. If we run git status again, we can see that all of the files are now staged. That means all of these files will be committed. We can now run git commit -m and then type a message in quotes to say what this commit is. Usually I like to write my commit messages as the finish to the sentence that began with this commit will and start with a capital letter. Some people like to include emojis in their commit messages too. It's up to you, but I recommend picking something and being consistent. Now that we have a commit in our history, we can view the log. Type git log to see the list of commits. We only have one here. This commit was done on the main branch. Usually when working on a feature or bug fix, you would be working on what's called a branch. Branches make it easier to have a bunch of small commits that all relate to something bigger. Then, when the feature or fix is finished, you can merge that branch back into the main branch. To make a new branch, you can type git checkout -b branch name. Branch names can only contain letters, numbers, and hyphens, and you should try to keep them simple. If you want to see a list of your branches, you can type git branch, and you'll see a little indicator next to the current branch. Now that we have our branch, we can work on stuff and make a bunch of small commits as we do things. Before a commit, if you want to see what changes you've made, you can type git diff, and it will show you what's called a diff between the committed files and your changes. If you have a long diff, you might need to press Q to go back to the command prompt. After that, commit your changes like we did before. Then, when we're happy with how it's all working, we can run git checkout main to go back to the main branch, and then git merge other branch name to merge it in. If you want to be a bit tidier with your feature branch merge commits, then you can use the squash flag. When merging in a branch, you can type git merge -- squash branch name, and it will condense all of the small commits in that branch into a single stage change in the current branch. Here, I'm in main. Then you can commit it with a single message as though the whole other branch was just one commit. This is the way I prefer to do things because it makes the history easier to follow. Each commit in the main timeline is then a whole block of work that belongs together. Of course, doing it this way means you should make sure your feature branches are focused on solving only one thing. In other words, don't do stuff in a feature branch that is unrelated to the task at hand. To remove a branch that you're finished with, you can type git branch -big D branch name. Now, one last thing before I start talking about GUIs and remote repositories: tags. Tags in Git are just pointers to a particular commit and are mostly used for versioning. For example, here is the repository for my Dialog Manager add-on. Each time I do a release, I create a tag that points to where in the timeline that release came from. For my game Brave as Coconut, I use tags to help keep track of the versions that I've put on Steam and given to testers. Okay, initializing, committing, branching, merging, and tagging. Now that you've seen it on the command line, let's have a look at some graphical interfaces that should make things a little easier. One of the more popular ones, especially if you're using GitHub, is GitHub Desktop. It starts by asking you to sign into GitHub, and from there you can add your repositories. Here's the dummy repository that I was using earlier, and you can see GitHub Desktop showing the history. We can click on commits to see their diff. If I make a change to a file and come back, you can see the file shows up ready to be committed. The blue checkbox here is like a shortcut for staging files. We can type a commit message down here and press the commit button to commit the changes. We can click up here to see the list of branches and to create new ones. You can also publish your repository to GitHub either publicly or privately. And now other people on your team can pull down the repository and make changes in their own branches. Now we can introduce something called a pull request. Let's say you're on a team and you've finished a feature and have it on a branch. From GitHub Desktop, you can publish that branch and then create a pull request. Once the PR is accepted, it can be merged from the GitHub web interface. GitHub Desktop will periodically check the remote repository for changes to any branches, including the main branch. If there are changes, you can pull them into your local copy of the repository. So you kind of get into the cycle of have idea for feature, create branch, commit changes, create PR, merge PR into main, repeat. Now you don't have to use GitHub or GitHub Desktop. A lot of people don't. There's a bunch of alternative cloud repository options as well as graphical interfaces. Sublime Merge is a pretty good GUI and reasonably priced. Personally, I use a thing called LazyGit, which is a terminal user interface, or TUI, rather than a GUI. As for cloud repository options, the most notable alternative to GitHub is codeberg.org. They all use what is called a remote, specifically the origin remote. So when you push to and pull from origin, it is referring to your repository on GitHub or Codeberg. When you clone a repository down to your local machine, it will generally configure the origin remote for you. If you just have your repository on your local machine but want to set up a remote on somewhere like GitHub, you can do that too. When you create the repository, it will tell you the steps you need to do in order to configure your origin manually. Once you've done that, you can push your local repository up to the origin. There's tons more to learn about Git, but I think that covers most of the basics. The main thing is that you're using some kind of source control. So that's all from me for now. Bye.